everyone, Mrs. Kovacs here, and I'm going to be talking about how to create multiple representations, so graphs, tables, and equations, when you're given a linear situation. So basically a word problem. A word problem specifically where you're given something that is growing at a constant rate. In this case, we're actually going to look at two situations simultaneously and then answer a question about the data that we're looking at. Let's start by reading the question and underlining the key information. Jackie and Carlos are going to have a tricycle race. Carlos's tricycle is way too small for him, so Jackie agrees to give him a 5-meter head start. That's a number, seems important. Carlos rides 3 meters every 2 seconds, and Jackie starts from the starting line, so she doesn't get a head start, and rides 5 meters every 2 seconds. Who will win the 20-meter race? Create multiple representations to support your answer. So that's going to be graphs, tables, and equations to support our answer of who is going to win the race. So since we are given two different situations or two different riders, I'm going to separate them by highlighting, and that's going to allow me to keep all the information straight in my head. So first let's look at Jackie. So Jackie starts from the starting line and rides 5 meters every 2 seconds. And then Carlos has a 5-meter head start and rides 3 meters every 2 seconds. And then remember what we're trying to answer is here at the end, which is who will win the 20-meter race. Okay, so I actually find that the easiest way to start is to make tables. You don't have to start with tables, but I feel like they're the easiest way to kind of keep track of information. So to make a table, you're going to make basically a big T-chart. One for Carlos and one for Jackie. Carlos and Jackie. And to think about what we're actually measuring, we want to look back to the units that they gave us for our numbers. So the first unit that they gave us was meters, and the second unit that they gave us that we were measuring was seconds. And so those are going to be what we're measuring. You usually want the more interesting thing, or the thing that is different for each rider in this case, to be the y coordinate. Another thing to keep in mind is that time is almost always the x value. So we're going to say that x represents the time in seconds. I'm going to zoom in a bit. And y is going to represent the distance in meters. So first they tell us that Carlos, oops, I just realized I made that all the wrong color. That's okay, I can fix it. There we go, Carlos was blue. So the first thing that they tell us is that Carlos gets a 5-meter head start. That means that after 0 seconds, he's already 5 meters into the race. So we go with 0 and 5. The second piece of information is that he rides 3 meters every 2 seconds. So that means that our x value is going to increase by 2, and our y value is going to increase by 3. So up by 2 and up by 3. After that, our job is just to continue the pattern. So 0, 2, 4, 6, 8, 10. I'm noticing that our graph only goes up to 10 for x, so I'll stop there. And then our y values were increasing by 3. So 5, 8, 11, 14, 17, and then 20. Next, we're gonna look at Jackie. So I'm gonna use pink for Jackie. So these are gonna represent the same things. I'm not gonna rewrite time and distance. I'm just gonna use X and Y. So they tell us that she started from the starting line. That means that after 0 seconds, she was just at 0. But she's going a little faster. So after 2 seconds, she increases by 5 meters. So our seconds column is gonna go up by 2s, just like Carlos. And then our Y column, our distance, is gonna go up by 5. So 0, 5, 10, 15, 20, 25. And now we can see when we're looking at our question, we can already see who won the race from our tables, right? We are looking for 20 meters. So we can see it took Carlos 10 seconds, whereas it only took Jackie 8 seconds to win the race, which means that Jackie would be the winner. Let's take a look and see what this looks like on our graph. So before we start, I want to actually label our axes. So this is our y-axis and our x-axis. And y is representing the distance in meters. I'll use m for meters. And then x is representing the time in seconds. So we could actually just plot the points that were given, but I do want to make a clear connection between the situation and the graph. So Carlos was given a 5 meter head start, which means that his y-intercept is 0, 5. Then they say he goes 3 meters every 2 seconds, which means that he is going to increase by 3 and go right by 2 to get to our next point. Then we just continue that pattern, 1, 2, 3, over by 2. Until we hit our 20 meter mark. I'm gonna erase the second box that I made there, just for not cluttering up the graph. Let's see if the line behaves. It does, good job, okay. And I'm gonna put a C there so that we remember that this is Carlos. Next we'll do Jackie. So she starts from the starting line, which is 0, 0, and increases by 5. Every 2 seconds. So up by 5, right by 2, up by 5, right by 2, up by 5, right by 2, and we're going to continue that once again as far as we can, in this case up to the end of the race at the 20 meter mark. And that is Jackie. So from the graph, how do we actually see who won the race? So if we were asked to just use the graph, we could look and see, we're looking for 20 meters. So we'll see 20 meters on our y-axis. And then we'll look over to the right to see that Jackie gets there in a shorter amount of time. And so this would be a super clear way to show on the graph how you can identify the point where Jackie, or the reason why Jackie is the winner. And that was our graphs. We just have one representation left. We made tables, we made graphs. Now we're going to talk about the equations. So if you've been watching the other videos, then you know that we've been working with the equation y equals mx plus b. In a situation, m, the slope, we can also think about as the growth rate or the speed. And our y-intercept, b, we can think of as the starting value, or in this case, the head start. And that's going to be applicable to any like y equals mx plus b type situation where you're starting at a certain place and then increasing or decreasing at a set amount. So let's start with Carlos's equation. I'm going to use a C for Carlos. So in this case, we're looking at our growth rate, which is our speed, and our y-intercept, which is our head start. So we know from the situation that his speed was 3 meters every 2 seconds. So we're going to represent that as our slope ratio, 3/2. And that the head start was 5. Our y-intercept, in other words, was 0.5. And that will give us our equation, y equals 3/2x plus 5 for Carlos. Next, for Jackie, same thing we'll do here. Y equals mx plus b. The slope is going to be our speed. The y-intercept is going to be our head start. So Jackie's speed was 5 meters every 2 seconds, which I can write as 5/2. And she didn't have a head start, so we could write plus 0, but more often than not, we'll just not write anything at all, because adding 0 is the same as adding nothing. And there's our 2 equations. And if we want to support our answer, remember we are trying to figure out, if we were just looking at the equations, how would we know who won the race? And so to do that, we can actually use some cool algebra. Remember that they told us that we had a 20-meter race that was given in the problem. So in our situation, y represents distance. So we're going to plug in our distance that we're looking for in each case, and we're going to solve to figure out the time. So we are looking for a distance of 20 meters, and then we're going to solve. Now I'm going to make this a little bit smaller so that I have room to solve, but I can zoom in, don't worry. Okay. So I'm going to show the solving steps in between afterwards, in case you need them. So if we can do our solving process, we'll get 15 equals 3/2x. We'll divide by 3/2 on each side to get that x equals 10, which means it took Carlos 10 seconds to finish the race. Let's take a look at our work in between. So how did I get from here to here? We wanted to isolate our x value, so we subtracted by 5 on each side. That's where we got 15. Then we wanted to isolate x, which was being multiplied by 3/2, so we can divide both sides of our equation by 3/2. You'll probably want a calculator for that, and that's where we got x equals 10 seconds. Oops, that's not a highlighter. There we go. We can repeat that process for Jackie over here. So plug in 20 for y, because that was our distance we're looking for. And then solve for x. In this case, we just have one step, which is to divide by 5/2 to isolate x. And that's where we will get x equals 8, which tells us that it took her only 8 seconds to finish the race. So Jackie won the race, finishing in 8 seconds, versus Carlos's 10 seconds. Notice how I was pretty specific by bringing in those exact x values, and I was able to use some highlighting to show exactly where we see that information in our table and graph as well. Thanks for watching. For this one, there's really just one main thing to remember, and that is how to write the equation. So for this specific type of situation where you're looking at something that's growing at a constant rate, you're going to still have y equals mx plus b. And m you can think of as the slope, but in a situation, what you're really looking at is the growth rate. Or when you're like in a race, it was the speed. And then the b value, which is the y-intercept, in a situation, you can think of that as the starting value. And I think that's the main thing that you want to keep in mind when you're looking at these situations. There's other tips and tricks, like we highlighted information, we made it really clear how to find what we were answering in each representation using like arrows and highlights. And that's about it.